the queen. I'm everything she lacks. You're the man, but I got the power. You make rain, but I make it shower. You should know I'm the one who's in control. I let you come to the wind long as you don't forget.
Who got the power?
Hello everyone! Welcome to our podcast. Atomic Talks, we're going to travel back in time where our great scientists are studying the atom. I'm your host. We also have our main host, Micah Canino, and she will be joined with two more hosts, Florey Mae Suyom and Danniebelle de la Torre. In today's episode, we will talk about the scientists that contributed to the atomic theory. And always remember to think like a proton. Think positive. We're going to be joined by our special guest, so wait until the end of this podcast.
What do an ancient Greek philosopher and a 19th century scientist have in common with the Nobel Prize winning scientist? Although they are separated over 2,400 years of history, each of them contributed to answering the eternal question, what is stuff made of? The first scientist known as the laughing philosopher because of his emphasis on the value of cheerfulness. He was also one of the founders of ancient atomist theory, Democritus. Democritus was a Greek philosopher who was the first to use the term atom or atomos, meaning indivisible. He was born at 460 BCE in Abdera, Greece. He called this the theory of the universe. All matter consists of atoms, which are bits of matter too small to be seen. There is an empty space between atoms. Atoms are completely solid. Atoms have no internal structure. Each atom of a different substance is different in size, weight, and shape.
The next scientist was known for his first contribution to the society, a description of the defect he had discovered in his own and his brother's vision. This paper was the first publication on color blindness, which for some time thereafter was known as Daltonism. John Dalton. John Dalton was the first to adapt Democritus' theory into the first atomic model. In John Dalton's atomic model, it says that all matters consist of tiny particles called atoms. Atoms are indestructible and unchangeable. Elements are characterized by the weight of their atoms, and when elements react, it is their atoms that have combined to form new compounds. Since then, chemists have shown the theory of Daltonian atomism to be a key factor underlying further advances in their field. Organic chemistry in particular progressed rapidly once Dalton's theory gained acceptance. Dalton's atomic theory earned him the sobriquet "Father of the Chemistry." The scientist that we will be discussing is an English physicist who helped revolutionize the knowledge of atomic structure by his discovery of the electron in 1897. He also received a Nobel Prize for Physics in 1906 and was knighted in 1908. Sir Joseph John Thomson. J. Thomson was a physicist who is credited for discovering the electron. He used his research on cathode ray tube technology in this discovery. Using what he had discovered, Thomson predicted what an atom should look like. These are the key points to Thomson's atomic model on cathode ray tube technology in this discovery. 1. Because of its design, this model is known as a plum pudding model. 2. Each atom is sphere and filled with positively charged fluid. This resembles the sticky jam part of the pudding. 3. Corpuscles, or later called electrons, are the negatively charged particles suspended in this fluid. This resembles the plum in the pudding. 4. He did not predict the movement of these electrons. J. Thomson was an excellent physicist and did not stop when he had found this negative charge. Through a series of clever experiments, he was able to predict the mass of this charge. He then found out that this charge was 1,000 times lighter than a hydrogen atom. He made a bold statement saying that this negative charge must be inside an atom. This negative charge, or he called corpuscles, later become known as the electrons.
This fourth scientist was born in New Zealand. He's also one of the first to come up with novel ways to use high-frequency alternating currents in experiments. Ernest Rutherford. Ernest Rutherford was not convinced about the model of the atomic proposed by Thomson. He thus set up his now famous gold foil experiment. The Rutherford's atomic model, aka the planetary model. The nucleus of the atom is dense mass of positively charged particles. The electrons orbit the nucleus. A problem raised was, why are the negatively charged particles not attracted by the positively charged nucleus? Rutherford stated that the atom was like a mini solar system, and the electrons orbited the nucleus in a wide orbit. That is why it is known as the planetary model. However, the gold foil experiment, he fired alpha particles, positively charged, at gold foil. He measured the deflection as the particles came out the other side. Most of the particles did not deflect at all. Every now and then, a particle would deflect all the way back. He said that there must be a positive center of the foil. He called the center the nucleus.
Our next scientist is a Danish physicist who is generally regarded as one of the foremost physicists of the 20th century. He was the first to apply the quantum concept, which restricts the energy of a system to certain discrete values, to the problem of atomic and molecular structure. For that work, he received the Nobel Prize for Physics in 1922, Sir Niels Henrik David Bohr. Niels Bohr agreed with the planetary model of the atom, but also knew that it had a few flaws. Using his knowledge of energy and quantum physics, he was able to perfect Rutherford's model. He was able to answer why the electrons did not collapse into the nucleus. Bohr's atomic model, aka the Rutherford-Bohr model. Electrons orbit the nucleus in orbits that have a set size and energy. The lower the energy of the electrons, the lower the orbit. This means that as electrons fill up the orbitals, they will fill the lower energy level first. If the energy level is filled or at the capacity, a new energy level will begin. Radiation is when an electron moves from one level to another. Problems with the theory? Electrons do not travel on a specific orbit or path.
Our last and final scientist is an Irish physicist. He combined the equations for the behavior of waves with the de Broglie equation to generate a mathematical model for the distribution of electrons in an atom. The advantage of this model is that it consists of mathematical equations known as wave functions that satisfy the requirements placed on the behavior of electrons. Erwin Schrödinger was a revolutionary physicist who used Heisenberg's uncertainty principle to come up with the atomic model that we use today. The Schrödinger's atomic model, aka the cloud model. An electron does not travel in an exact orbit. We can predict where it will probably be. We cannot say for certain where it is, but only where it ought to be. The type of probability orbit is dependent on the energy level described by Bohr. Those were the six scientists who contributed on the atomic theory. To sum things up, the smallest part of an element is called an atom. An atom can be divided in smaller subatomic particles, and these are protons, electrons, and neutrons. Within each of these levels are special types of orbitals. These depend on the energy level. Each orbital can contain two electrons. As we go up the periodic table, an electron and proton are added. So those were all the scientists who contributed on the atomic theory. We hope that you are learning and having fun while listening to our podcast. And always remember to think like a proton. Think positive. Before we move on to our next topic, let's have a break and energize our brain. Just sit back and relax while listening to our music. We'll be right back, so stay tuned.
I am the queen. I'm everything she lacks. You're the man, but I get the power. You make rain, but I make it shower. You should know I'm the one who's in control. I let you come take the wind long as you don't forget.
Who got the power?
Welcome back to our podcast. I hope that you had a wonderful break while listening to the music. And I also hope that your brain got energized so you'll be ready for more learning. So, what are we waiting for? Let's continue to talk about more of the atomic theory.
Hello, everyone, and welcome back to our podcast. I hope that your brain is all set and energized to learn more. Before anything else, we've got a surprise for you all. We invited a scientist who's atomic theory. He and one of those are the Nobel Prize in Chemistry, Copley Medal, Matteucci Medal, Elliott Cresson Medal, Rumford Medal, Bernard Medal for meritorious service to science. Let's give a warm big round of applause to Sir Ernest Rutherford.
Thank you so much for that wonderful introduction, Mr. La Torre. It is such a pleasure to be here. I really admire you all for discussing the atomic theory.
We're also thankful for your presence, sir. So, shall we start?
Yes, of course. Greetings. My name is Ernest Rutherford, and I was born on August 30th in Nelson, New Zealand. In our family, I was the fourth kid and the second son. James Rutherford, a wheelwright, was my father. My mother, Martha Thompson, was a high school English teacher. My first name was misspelled on the birth certificate. Instead of Ernest, it was Ernest. I acquired my early education in government schools and entered Nelson Collegiate School at the age of 16. I received a university scholarship in 1889. I then went to Canterbury College at the University of New Zealand in Wellington. I earned my MA in the year 1897 with a BSc with a bachelor's degree the next year. When the MacDonald Chair of Physics at McGill University in Montreal became vacant in 1898, I jumped at the chance to apply for it. I began working with JJ at Cambridge. Thomson's research on the conductive effects of X-rays on gases led to the discovery of the electron in 1897, which he announced to the world. I observed that thorium formed a gas that emitted a radioactive emanation that would coat other compounds. I concluded in 1903 that a form of radiation identified by French chemist Paul Villard in 1900s as an emission from radium had to be something different from his own alpha and beta rays because of its far greater penetrating ability. In 1907, I became professor of physics in Manchester, succeeding Sir Arthur Soster. In 1919, I accepted an invitation to become Cavendish Professor at Cambridge. I also serve as chairman of Advisory Council for HM Government's Department of Scientific and Industrial Research. When I was hit with alpha particles, I discovered that hydrogen nuclei were a part of nitrogen nuclei, which I dubbed a hydrogen atom. My interpretation of the findings led to the formulation of Rutherford model of the atom in 1911, a very small charged nucleus orbited by low-mass electrons, holding much of the atom's mass. I theorized about the existence of neutrons in 1921 while working with Niels Bohr, which could somehow compensate for the repelling effect of the positive charges of protons by causing an attractive nuclear force and thus keep the nuclei from flying apart due to the repulsion between the protons. My neutron theory was initially published in my Bakerian lecture in 1920. By creating an attractive nuclear attraction, neutrons compensate for protons' repelling effect, preventing nuclei from flying apart due to protons' repulsion. For this discovery, Chadwick received the Nobel Prize in Physics in 1935.
Thank you so much, Sir Rutherford, for sharing your story with us. We're sure that our listeners was also happy and inspired by hearing your story. Now that Mr. Rutherford shared his story, we have some questions for him. Are you ready, Sir Rutherford?
Yes,
We have three questions prepared for you, Sir Rutherford, and you have a minute to answer each of them. Our question is, what is the inner structure of the atom which caused such scattering led to the postulation? The clue is, it is your greatest contribution to physics.
oh, the nucleus.
And your answer is correct, Sir Rutherford. Thank you for answering my question.
You are very welcome, Miss Suyom.
Hello po, Mr. Rutherford. My name is Micah Canino. This is the second question. Do you know who adopted your nuclear structure to Max Planck's quantum theory? The clue is he is also a scientist.
Yes, it's Niels Bohr.
Your answer is correct. Thank you so much for answering my question, Sir Rutherford.
You are welcome and have a nice day, Miss Canino.
So far, you answered all of them correctly. Congratulations, Sir Rutherford. So our last and final question is, what inspires you to be a scientist?
I came from a poor family. I am the fourth child out of the 12 children of my parents. My family is big and we are struggling with our finances. Because of that, I strongly believe that knowledge is power. We don't have the money, so we've got to think. I invested my time learning. These things that I make and discover during my time as a scholar student fuels me to pursue greater achievements. That with these experiments, I can change my family's life as well as to make a contribution during this age of discovery.
Thank you so much, Sir Rutherford, for answering my question.
You're welcome, and thank you as well, Miss Dela Torre.
Thank you so much, Sir Rutherford, for accommodating our invitation to join our podcast. Our listeners are really learned a lot from you, especially when they heard your story. I'm sure that you inspired most of them to become a scientist as well.
Well, that's really nice to hear that a lot of people are getting inspired to also pursue their dreams.
I'm Micah Lorine Canino, your main host.
I'm Florey Mae Suyom, your adorable host.
I'm Danniebelle de la Torre, your shy host.
And I'm Jeanica Bianca Venzuela, role-playing Rutherford.
We are the Atomic
Atomic
Talk.
Talks, and always remember to think like a proton. Think positive.
Think positive.
Thank you so
Thank you
much
so
for
much for
listening.
listening.
We'd like to thank those of you who have been listening to our podcast since the beginning. We hope you have all learned something new by spending your valuable time listening to us. We appreciate you guys listening to our podcast on a regular basis. And we'll see you on our next adventure. I am Phoebie Milgo, your beautiful host.